Welcome to the live session tutorial. In this video here, I'm going to actually go through the PowerPoints in a little bit more detail so that you can play them over and over again, stop them as you see fit. I've created a bunch of links from which I've got some of the data from. So it's a combination of the PowerPoint that comes from the book and a lot of my own slides. So there's also going to be some duplication and a review at the end. So what I'm going to do here is just take it step by step. Now it does say Chapter 7 for the title, but it actually has a lot of Chapter 8 in it as well. So hopefully you will get a lot out of it. SQL is not as intimidating as you might think it is, as it sounds. However, I'm going to go step by step with it, and I've created much of examples that hopefully will make it much, much easier for you. So these are the objectives that we want to have in here. And the first one is the basic commands, how to use SQL, and you can read the rest of those on your own. This is also in the modules in Canvas. And then the categories. The two important things are DDL and DML. They're just different acronyms for the types of commands. The data definition is going to create and alter tables, and the data manipulation are the things like insert and also to add columns and to do different things as far as whatever you need to do to select data. So basically, I've defined SQL. It's not my definition, but basically, it's not a programming language. It's something you understand. It has to be in something else in order for it to do. Just like if you were to create a C++ program, you can do that in Notepad, but unfortunately, that's not going to happen. You have to have that within a C++ compiler. Well, SQL has to be inside a DBMS such as Access, SQL Server, MySQL, Oracle. So again, we talked about the DDL, we talked about the DML, and then there's a data control language which is used for manipulating accounts permissions, such as authentication and user accounts. So here are the data definition language: create, alter, and drop. We're going to concentrate on create and alter. So you create a database using the create command, very easy. Create table, you obviously need to have the table name, and then the fields that you want and the data types in here. Alter is, oh, I forgot a field, or you want to add a index. You can do that with alter, and drop allows you to delete something that's already in a table or an entire object by itself. So here's the syntax. It's very simple. Create the table. Notice the capitalization of the SQL phrases and reserved words. Then employee is the name of the table. There are different ways of naming. I am preferential to a table beginning with a capital letter and the rest lowercases, as well as the attributes or field names, all uppercase. That makes it much, much easier to distinguish which is which. So we have employee, then employee ID is an integer and it's not null. Now the not null is not required. However, you do not ever want to have an ID as not null. They can put nothing in there. And we're going to add an index to that later on. And an employee name is a character 25. Yes, I know that if you go into Access and do the drop down arrow, you will see short text and long text and not character 25. But this is what the SQL will do. If you try to do it with short text or long text, you'll get an error, which is not good. Now notice the left parentheses opening up, the right parentheses, and then the semicolon. And notice right over here, there's a comma and no comma. The very last one does not require a comma, but separating the field names does. So again, we have another one. Here's an example: create table persons. Person ID is an integer. Last name, varchar. Varchar is a variable character, which means it reserves up to 255 characters, but won't use 255 characters. If you do character 255, then everyone's going to be 255 characters. And this I copied, so it does not follow the standards that I did with the, should be all person ID in there, all capital letters. So for simplicity's sake, please bear with that and understand it. Again, we have a create table. Now what we've done here is we realized we forgot to put a primary key. So all you're doing here is you're putting in what is called a constraint. And a constraint means some kind of rule in here. So basically what we're doing here is employee PK, we're naming it. The constraint is not required, but I'll explain that in the next slide. Then you have primary key is a keyword, and then what field are you going to? That will make it not null, and it will make it unique. You could not put in the same primary key twice. So again, we have create table, employee skill, and again, now this is mine, so I've followed the standards of the capitalization of every word in a table name, and then all capitalization. So we have now notice the employee EMPSKey underscore EMPID. It refers basically to the same ID, but you can see going back to the last slide, it just says employee ID because it's employee table. So here we have skill ID, skill level, again, constraint, and then we're naming a primary key. But here we're actually using a compound primary key. So we're going to key on both the employee ID and the skill ID. Here is the statement without the constraint. So basically, we're not putting in constraint. However, notice we cannot name the primary key or formary key in here. So again, let's just put over here. It does the same thing, but does not allow you to name the constraint. Then we have an example over here, basically the same thing. And now, but what we're doing here is we're doing a foreign key and we're referencing it over here. Make sure that the tables have these fields in here. You will get an error if you're trying to enforce referential integrity. It will not work. That's why it's important to create your relationships right in the very beginning over here. So everything here is the same, but what we're doing here, we're doing a foreign key, and we're referencing the employee ID in here, and then another foreign key in here to do the other. So that we take care of that, and here's a visual representation of it. So you can see you have the three tables, and you have employee ID and employee ID here. Then you have skill ID and skill ID here. Notice that the employee ID is a primary key and a primary key. That's okay. The skill ID here is a foreign key and a primary key. However, the primary key here is employee ID and skill ID. And altering the table just allows you to alter the table. So here we're adding constraint. When you go, oh, I forgot to add the primary key. Then you can also do alter table. You can add a foreign key. You can add a table name, such as add email varchar 255. So all you're doing is alter table, the name of the table. You're adding an email. And you can drop a column, delete a column, but be very careful. There is no undo. What you're going to have to do is recreate all that. So if you have a column and it's got all kinds of data in it, and then you delete that one, then you're not going to be able to get it back unless you have a backup from it. So again, another example of how to do it, alter table persons, alter column, and now what you're doing here is you're changing the data type. Just bear in mind, if you're altering a data type and you do it to something illegal, for instance, if you have ABC in there and you try to alter the data type to numeric, you're going to run into a problem. More than likely, you're going to get an error when you try to run it. These are constraints that you can use, not null, unique, primary key, and foreign key. Then you also have check, default, and index. So I put in here the definitions. A check ensures that all values in column specify specific conditions, such as age less than 21 or age greater than 21. Default sets a value if you put nothing in, and index uses to create an index and retrieve data. So what I've done here, I put a link here, and a link here to W3 schools. So I'm going to attempt to access that link. And you can see over here that it goes directly to that. Okay, so we'll go to the next slide now. And inserting data is basically very, very easy. it's insert into, not just plain insert, the name of the table. Then you start listing the columns. You can use them all, or you can just use a few. If you do not name them, then it's going to go in order of the data table definition in here for the columns. And once you stop, you can't skip a column. So for instance, if you had 8 columns, you could do value 1, value 2 from the columns and name the column, and you could skip column 4 and go column 5, and then you would have value, value, value. Make sure you don't put 1 in. So the number of values is going to have to match the number of columns. You do not have to do that if you're going to just add all of the values in order. Just saves a little bit of writing. And here's an example. Insert employee, and then I have employee, salary code, last name, and the values 62, 11, and Jones. Now, if there's only 3 fields in there, you could have just done insert into employee, values 62, 11, and then Jones. Notice the quotes for Jones. Updating a record, you realize that you put some wrong information in. Very simple. You just update the column, the table name, and you whatever column it is. Again, column is field. So, however, the syntax are rows and columns. I have no problem if you use field. I have no problem if you use record for row, whatever you feel the most comfortable with. So what you're doing, let's just saying that we're setting a age. We realize he's 21, but it's in there 20. So you're going to put set age equals 21. And then you can put a condition in there. If you don't put the condition in there, well, you're going to set everybody's to the same one over here. So the where clause specifies which record or records should be updated. Again, I put this in here. I'm saying it and I'm writing it. If you omit the where clause, all records in the table will be updated. So again, update customers, Alfred Smith, City, Frankfurt, where ID, customer ID equals 1. Updating multiple records. I see a nice typo there, which I will fix. So update customers, set contact name, where country equals Mexico. So everybody that is from Mexico, the contact name is now going to be Juan. So again, it will update every customer from Mexico, and be very careful to use the where clause. So here's the where clause. Can use any of the follows, equals, the not equals is the greater than, less than sign, or exclamation point equals, greater than, less than, greater than or equal to, less than or equal to. You can also use and, or, and in. Same rules over here. If and, that means the city is Miami and employee age is 30. So if employee age is 31, it will not work. However, if you're using an or, if we did employee city equals Miami or employee age equals, so anyone who's 31, regardless of where they come from, is going to be satisfying the criteria. Or again, we're going to pull all the cities from Miami or all for Fort Lauderdale. Now be careful, if you have in there FT and no period, then Lauderdale, then obviously that's not going to be the same. It takes it literally. That's why you have things called like. And then in. So if, again, you have links to all these things in here. So the in is an easier way of saying, I want to pick a whole bunch of things to choose from. I don't want to have a separate or clause. So I'm just going to put department ID in 4, 8, or 9. That means anybody in department 4, 8, or 9, which is basically the same as saying department ID equals 4, or department ID equals 8, or the department ID equals 9. And then in, again, must match one of the values, otherwise it's not going to work. And this is a duplicate in here just to emphasize it. So here's the context. Now the select star means select all of the customers' fields, not just the ones that you want. If you want just specific things, then you select and you name the fields. If you want them all, choose the star. Now some of the databases may let you do without the star, but it's best to be consistent all the time. So again, we're going to select all the customers where the country's in either Germany, France, or UK. Now, if somebody is in the database as France and they spelled France wrong, it's not going to show up. So you have, again, those that are not in Germany, France, so that'll give you everybody that's in there with the exception of those in Germany, France, or UK. Between is good for numeric. So where the price is between 10 and 20, just remember that it is inclusive. So it's basically the same as saying price greater than or equal to 10 and price greater than or equal or less than or equal to 20. So 10, 11, 12, 13, 14, 15, all the way up to 20 will be selected in here. And then here is the best known query. This is a select statement used to retrieve information that matches a specific query. Example, you want to know all the people that live in Florida. So select employee name from employee, that's the name of the table, where employee ID equals 35, or you could put where employee city is or employee state is Florida. And here's the like keyword, and you can use this to make it easy to find stuff. I want to know everybody whose last name begins with D. So I can do that very easily from in here. Now, I put in some differences in here. In Access, the wildcard character is a star. In SQL Server, it's a %sign. And then the single character is a question mark, where in SQL Server, it's the underscore. So here's an example. We're going to get everybody whose last name begins with, or employee name begins with DA. If I wanted just D, I would put D. Now, bear in mind, case sensitive. If you put in all capital letters in the last name, it's not going to work. So I want people, area code is 305, so I make sure that it's 305, and I put a bunch of question marks. And here is your wildcard characters in Access, symbol, and the $, and so on and so forth, or rather the question mark. And here's examples where customer name like A, that's going to give you any value that starts with A. And then vice versa, anything that begins with A. Same thing here in SQL, and more examples in here. So the order by, I will discuss in the next video. I'm going to break this up into 2, maybe 3 videos so that you can watch them and not have to watch a whole thing in there. I try to keep my videos to less than 20 minutes. It is now a little over 17 minutes, going on 18 minutes, so we'll end it right there.